When I delineate my fire frequency by early dry season and late dry season, you realize that on A, that's early dry season, B, it's late dry season, you realize that we experience a lot more fires in the late dry season, and that's more than 90% of fire activity in the late dry season. But if you look at number one, that is only the footprint over 23 years from 2000. The reason I started from 2000 with this delineation between early dry season and late dry season was because with Moody's, I was able to take advantage of its return period and be able to say early dry season is going to be any date before July 31st, and then late dry season is any period after July 31st. So August, September, October, November, December, five months of basically late dry season. But in the late dry season with fires in Botswana, you would get August, September, October, and November you start basically not getting much. Any question? Fire scars and Moody's generated fire scars, creating that fire frequency index. You would realize that in terms of fire extent, there seems to be a decrease in the fire extent in the region. And that is something that we can then also discuss as to what would be bringing about the decrease, but it's in agreement with the international studies that even though fire activity may have increased, but in terms of the fire extent has decreased a bit. When I also mapped the fire here, I was identifying the early dry season and the late dry season, but the trend is mainly based on the late dry season. But in terms of early dry season and late dry season, you'll see that there are years that actually there was quite some early dry season burning compared to the rest of the years. I don't know what may have happened in 2002. And those are some of the information that, talking to the first three people, you may want to know what actually happened in that year. 2011, I haven't been able to find any information as to what was happening in terms of plans, whether there was a deliberate effort to light fires in the early dry season from the forestry department. But what I realized from information was that 2010 was the La Nina year, as Andrew described earlier, the La Nina. So you may find that if there was lots of rain in the preceding year, the following year you are going to get a lot more of that fire. So it could have happened that that was a wet season, and as soon as it dried up, you start getting fires. I don't know whether then it will allow to get fires in the early dry season more than in the late dry season. These are some of the things that we need to discuss and find out. But when you go to 2023, this is, and some of it basically starting from 2019, but 2022, 2023, and of course 2024 is where I was present in terms of early dry season burning. And you went to witness the helicopter burning or the drone burning. That's basically the method that was used during the 2022 and 2023 early dry season, and even 2024. So this one, it's coming out of the ramped up efforts of early dry season fire burning, prescribed burning. Excuse me. In terms of the fire activity in the region, the idea here is to come up with an ideology of fire regime. Basically, what influences the different parameters and different variables that influence the way fire burns in the region. So on the left, you'll find that it's a vegetation map. That vegetation map was actually derived through putting together different variables that could be, that was soils, NDVI, landscape relief, and a few other variables that then we were able to use through random forest classification to create a vegetation map like that. And I think that gave us about an accuracy of about 85%. So this one, you remember I talked about collecting some data using helicopter as one of the tools that we were using, and ground transects. We then validated this classification using the helicopter and the ground transects, and that's how we got the 85% classification. But what was happening is, from the helicopter, we could look down and say, with the way you are looking at an area, you could estimate that less than 10% of the cover was trees. And if it was trees, less than 10%, then you would say that is open woodland. Let me look at the different measures there. So for forest, it's anything that is above 60%. So anything between 30 and 60%, we give it to be woodland in terms of the tree cover in the area. It has that is the number one area here. It has very high fire frequency. It's a grassland. One of the other interesting things about the area is that it predominantly experiences late dry season fires. So in terms of the fire frequency index, we found it to be very high in the grassland and mixed grassland and mopane vegetation, but that is not a target for the savanna burning methods, as was explained by Jeremy in his presentation yesterday. The target is that Myombo ecosystem, which of course in some studies they say Myombo mopane, bringing the two vegetation types together. Open woodland and shrubland, we have fire frequency of 5 and 6, and basically what it means, if you say fire frequency of 10 to 11 in the number of years that we have used, it basically translates in one fire every 3 years. So every 3 years from 10 to 11, you have to have a fire. In the open woodland, the 5 and 6 fire frequencies, you'll find that translates to one fire every 5 or 6 years. Then we have the woodland and the forest areas. The forest areas in this context, like you can see, I said, is the areas that have the canopy cover of more than 60%. Would experience a fire once in every 10 years. And those are areas in the western, mostly on the western part of the project area in the district. And also in the area 9 and 10. Those, when you look at the classification map, you can see how this quite green, basically depicting the vegetation type that exists there as being forest. So you can see, you can relate the fire frequency to the vegetation type. Right. So in terms of the fire frequency, then you can see a little bit of how then we sort of like try to interpret it. You will say that in the forest areas, basically the fire frequency index is low. In the woodland, it's not as bad, and then it starts increasing with some of the areas in the Mopane grassland and in the grassland experiencing a fire frequency of 3 or up to 16. This one is actually 19. The highest fire frequency. 19 would be translating to about one fire every 1 year, 3 months, something like that. So basically it's a fire every year, not every 2 years, almost every year. There are areas like that experience a fire every year. So in terms of the results in the area, you would remember I was talking about how I was going back in 1991. We have 6 forest reserves there in the country. These are the forest reserves that I said the Norwegian Forestry Institute set up those plots. Now we are looking at those plots as our permanent sampling plots, and that's where I want to measure the tree matrix. And those are where the plots are located, the red dots. And you can see that we have some of the forest reserves that actually have a lot of fire activity, and some of the forest reserves that don't have much of the fire activity. You can see the one on the western part of the project area. And the green delineation basically shows where there is concentration of that Miyombo type vegetation. Going back to locate those plots that were tagged back in 1991, this is some of the situations that you find that some of those tags have been engulfed by the tree as it grows, and so it was a bit difficult to find those tags because you should be able to see a tag from a distance, say from about 100 meters. But in this case, you have to be very close to be able to see the tag. Sometimes it's not even possible to see what tree number that was, and you just give up and not destroy the tree and just save it and go for others. But now, in terms of preliminary assessments and preliminary data, because like I said, I'm working on 3 papers. My first paper is basically looking at the fire regimes, the fire frequency, what I talked about earlier. It's completed, submitted. It's reconstructing the fire regime of the location, including fire breaks and land use and other human activities. The second paper is basically talking about relating the fire frequency index to the development of the biomass in the area, especially in the living biomass. This is the medium fire frequency category. So there is a bit of a shift where now it seems like we did actually gain a lot more biomass during the difference between the 2 times because of the fire activity in that region. That's basically what we are attributing to the change at the moment because of the fire activity. But here in low fire frequency, you can see we don't have as much of a change as we do have in the medium fire frequency. So when you then look at other variables like rainfall or whatever, and in terms of just natural change, of course there may be some increment. But then the rate of change can also then tell us in terms of those different locations if there is actually effect coming from the fire effect. So you can see we have negative change in the high fire frequency, and in the medium fire frequency we have quite some good change. but not as much in the low fire frequency. Basically meaning we don't necessarily, this landscape cannot live without fire. So you can see, if we were basically to exclude fire from that landscape, we would not be able to appreciate the change in biomass as may be required. So this one is talking about the sampling of the soils. You would also appreciate the same effect we had with the above ground biomass. This one is quite interesting. I analyzed 3 profiles. The green being the top layer, and the yellowish being the middle layer, and the orange being the bottom layer. So in the high fire frequency, you have high soil organic carbon. Basically because as the fire burns, it leaves a bit more carbon on the topsoil. But then when you go into the deeper soils, you don't have much. But when you go to low fire frequency, there's a little bit of a change. You do have a bit of more carbon in the deeper soils. The medium fire frequency, which is basically what we would wish to see, we do have like a high soil organic carbon in the different soil profiles. And there was a question that was asked by Arthur, that maybe we do have some leaching to the deeper ground, and this may be one of the explanations. So we are seeing a lot more carbon as you go deeper into the soil. That's why when you look at this, you can see that in the low fire frequency, you start off with high fire category. Let me start with the high fire category. You start with a high soil organic carbon on the top layer, and then as you go deeper in the soil structure, you then sort of like have a reduction of the soil organic carbon. But in the medium fire frequency, you can see that it's actually stable. In terms of comparison with the other profiles. The low fire frequency, you start off with a bit lower soil organic carbon, and it sort of like stays low in the soil, in the mid layer, and then in the deep layer you get a bit more high soil organic carbon. Basically the last slides are showing the effect of fire on the woody biomass, and of course some of the damages you can see is caused by animals, and that would be elephants. And more of the elephants, they're basically digging up some of that vegetation. And this is the Brachystegia bunmei, which is one of the indicator species of our Miombo ecosystem.